Here we will go and choose the library. Here, directly we will single library, but multiple libraries. So here you add each and every library by putting. So you don't use this button. So here, what we do directly click on browse. Here you go to the home. To the home, we have Tanner tools. Go inside the Tanner tools, and inside the Tanner tools process. Inside the process, generate 250 nanometer. Inside the generate 250 nanometer, we have generate 250 nanometer devices. We have a double click on it. Here you can see it has CMOS. Here there are 25x, 33, 33x, 25. Here, what is 2.25? 2.5 voltage. 3.3 voltage is 33. X means it's a grounded one. Not grounded one. If you add almost 25, it will be grounded. So here I will show you a design video. Here you have to add only the generate devices. I will be adding as a library. So this library window. So now I will click OK. And I will click. So now here you can see generate 250 devices. Similarly, again I will right click. I will go to the add library and I will browse the path. And now I will go one step backward. This arrow is to go one step back. And if you go one step backward, now we have to go for the standard library. Here there are two libraries, standard library one. If you ask what is the difference between these two, standard library is for the 250 nanometer technology. In case using any library below 100 nanometer technology, for example 45 nanometer advanced, then you will be using the library 160. Same thing, what is our presenting standard library? Same thing, you can see in the standard library 160. But there is a you will use standard library 160 for below 100 nanometer technology, for 250 you will be using normal standard. We'll go inside the standard library. And here now what we have to do is we have to add the spice sources. So if whenever you have a free time, you can go and see inside the spice sources what are the things available. What are the available in spice products. So just as an example, if I wanted to, you have some design in your mind which you have to do, and you require certain components. Based on the components, if you require to design your circuit, you will add the library. So you require some component inside the spice product. Then only you will add. Others is not necessary. It's not like whether you have to add or not. If you doesn't want also, you can add it. Others, you can add whatever is required. So now I want a spice. Inside this, you can find the vehicles and the VB and the VDC, VSC, all these things are available. So these are the components. If you want to study like what is meant by vehicles, again you have to go with the basics. You can browse and just go through like what is common. So now I will just click OK and I'll add this. And now I will click add. And once after adding the spice sources, similarly I will go to add library again, same step you follow. So here I will browse. And now only one step back. Everything is inside the standing library. Here I am choosing whatever. I choose spice sources, and now I choose spice. Here you can find any phase node point, voltage ping. Voltage ping in the sense whenever you are doing the simulation, instead of double clicking on the input output to make the physical result, and if you add voltage ping, it will directly give you the waveform. So manually, it's not required you to double click and observe the waveform. So that for that we will use the voltage ping. Other than that, we have here device state register, print, and ammeter. If you want to use ammeter, any some complex design. For now, it's not necessary. I'm just showing you how to add this one. I will add this. And similarly, I will go to the add library and I will browse. And again, only one step back. Here, I don't want all these things. Now, I want only MISC. In MISC, I will be having the ground, VDD, all these things will be available uh, in this folder. I will just click OK and I will. So, for me, this is more than enough to design the circuit which I'm going to uh, So here add library, I did only two things. Okay, one is everything was inside the standard libraries. I added only spice plot, spice sources, MISC. You want, you can add other things also. For me, it's not necessary, so I'm not adding. And other thing was generic 250 nanometer. Here I added the generic 250 nanometer devices. For the caliber, you will be having the rules file here. I will just explain that while I explain you. Now I will just cancel this. Now I have added the necessary library files. Once after adding the necessary library files, if you click on the library files and you just go to all, here every components will get displayed. Here you can see the components, and here you can click it. If you go to spice sources, each and every component you can observe how it looks like. And if you go to the MISC, all ground, everything will be visible. So now I want to design a circuit. For designing a circuit, what I have to do, I have to create a cell first. I'll click on cell and I will click on new view. And here I will, the library name is automatically selected. And here, whenever you're giving the cell name, the name which you're giving in the schematic, even in the layout, it should be same because you are doing LVS and all. So it should match each other. So what I will do is I will give the name as inverter. I will give a small inverter. You can give any name, even you can give your name also. Here view type it is schematic. It will be selected in default. In case if it is not selected, you have to make it as schematic. So sometimes it will be in symbol. If you add symbol, again it will be given issue because we are designing a schematic. So click on schematic and you click OK. So the cell is formed. So this is the cell and maximize this cell. And to make it you can click the home button. If you click on the home button, it will fit into the screen. To fit into the screen, you will be using shortcut home. And to zoom in, you will use shift plus plus. Shift plus plus to zoom in. And minus to zoom out. Only minus to zoom out. And home to fit into the screen. You can just note down that home to fit into the screen, shift plus for zooming in, and minus for zooming out. And now I will design the circuit. So I will click here and I will type I. I means I am adding the instance cell. To add the instance cell, now what I will do, here you can go and select whatever the files. First I will go to generate 250 nanometer devices. It's not like only for the inverter the same procedure. Its procedure is same for all the circuits. I am designing one circuit here, that's it. If you want to design whatever the circuit, the steps will be same. This is the complete tool flow. And now here what I will do, I will add the PMOS and the NMOS. So I will choose the 2.5x. I will choose the ungrounded one. I will not take grounded one. If it is 25, it will be grounded one. If it is 25x, it is ungrounded one. So I am choosing NMOS. As I told in the morning, NMOS is a pull down transistor. It's not a pull up transistor. So I will place in the below. And similarly, I will go and I will choose the NMOS. NMOS 25x. And I will place it above since it is a pull up transistor. And I will click OK. Done. So I have added the PMOS and NMOS. Inverter is too simple. You require only PMOS and NMOS, and you will make the input and output connection. Add a ground, add a VDD, and the circuit will be ready. It's a simple circuit. In case if it is a NAND gate or OR gate, what you will do, you require more number of PMOS. Like you require, it will be two inputs will be available, right? VA and VB, not only VA. So it will be like a parallel circuit you have to design. In VLSI, I would have designed the circuits and all for the Boolean functions, whatever they have given. Similarly, you have to add the circuit and you can do the simulation. So now I will just place it above. And for moving this one, you can use the mouse center button. Just hold it and click on the, just you have to click on this. After clicking on this, yellow color will appear and click the mouse center button and you can move it. Or else even you can use control. You can click on this control and you can move this. If you hold on control and then you can use this. So not control, alt. Either alt or here mouse center button. Now I will fit into the screen. Again, I will type home. Now I have to make the connection using the wire. Here you can see this is the wire. If you click on this, it will show wire tool. Now I will make a connection. So before making the wire connection, and if you want to come out of the wire, here there will be a arrow. Select tool. If you click on this, it will come out of the wire. Arrow simply it will be you will be dragging with the wire. So now I will click on the wire and I will make the connection. So I have made the output connection here. And you can click escape. If you click escape, it will be removed. And similarly, I will make the input connection. Again, I will click on the wire. It's a gate to gate connection. Hmm? Not required. Hmm. So now I have added this. And similarly, again, I will click on the wire. I have not taken grounded here. So I'll make the connections here. Base to source. After making these connections, now I have to give the input output. So here you can find the input port, output port, and in case if you want to add the in-out port also, it's available. So I will select the input port first and I will type it as V in and I will enter. Similarly, I will go and I will choose the V out and I will enter V out. And similarly, what I will do is I will take this one input port and I will add the VDD directly. And similarly, I will add the VSS. Either ground or VSS, anything is fine. I will give VSS. So whatever you are giving here, once after completion of the netlist, once you get the netlist, you will launch the layout, right? There, you will get the 4 separate columns like VDD, V in, V out. There you have to place that inside the connections, like base to source connection will be there, gate to gate connection will be there, drain to drain connection. So this is the base to source connection I am doing. And here its output will be the drain to drain and gate to gate connection will be the input. Similarly, it will work. These are all like basic things. If you know the basics of the CMOS everything, you can make these connections. So here I have added the connections here. That also you can take. Since it's an inverter, it's not necessary. Like in case if you are doing some complex circuit, it may require some functionality. At that particular time, now what I will do is, I will not directly run the simulation. I will form a test bench now. I will convert this to the inverter. I will generate a symbol. And that symbol, for that symbol, I will add the VDC, pulse. Because voltage should go right. If I give the voltage only, I will get the functionality through simulation. So now I have added this. The circuit is simple. I hope you understood. This is a pull-up transistor, pull-down transistor. Input connection, base to source connection. I have given VDD, VSS. Here, either you can give ground instead of VSS. You can give ground connection through MISC and VDD connection through MISC. This is not necessary, or else you can give this also. Anything is fine. I've added this. Now, what I will do, I will do Control S. And here, you should not directly connect to the wire. You have to extend this using a wire so that it will not get short circuited. To prevent the short circuit, will add the extra wire. So what I will do is I will click on this. Once yellow color appear, click on center mouse button and drag it. So if you click on center mouse button and drag it, it can be elaborated. Similarly here. Now you click on the home and I will do control save. Now the design is ready. And now I have to see whether my design is proper. Do I get any errors? So for that, what I will do, here in the tools, you can see design checks. So you can click on design checks and click view. So here you will get the design check complete. One cell has been checked, 0 errors and 0 warnings for found. If there are any errors, you will get the errors here. Or else you can directly check, click here also. Connectivity. Only connectivity. So here if I doesn't extend this wire, then you will get a warning because short circuit may happen. For that purpose, as an initial precaution, I am dragging. So this is once it is completed, now the circuit is ready. Now what I will do is I will click on the cell. And in the cell, I will click on generate symbol. Generate symbol in the sense, whatever the inverter I am designed, I am converting it as a schematic. So I will click on generate symbol. And I will click replace. There is an option called replace. So if you click on replace, it will be converted into the inverter. So now what I will do, I will just go to the cell again. Here it is a design check. If you go to the here, you can change it to the libraries. Here there are 3 options: hierarchy, net highlighting, design check, and libraries. So now what I will do is I will go to the cell and I will create another new cell, new view. Here I will give inverter test. Inverter test. So whenever you do the design, it is the better way to follow. Instead of directly creating the circuit and running the simulation and going to the layout, better generate a symbol first for your circuit. Then you add your other standard libraries required. Standard libraries in the sense, here I have not added any standard libraries. You saw only I added PMOS and MOS. I added input output ports and I connected through the wire. Even in the ODT also same flow they are showing. They are generating a symbol. Okay. So inverter underscore test, and here you can see it's in symbol. If you directly click OK, then you will get an error. So it is a schematic. So you have to click schematic and click OK. Now the new cell is formed. First, what I will do, I will click on I. I is an instance cell. First, I will go to the schematic here. Once I go to the schematic, here first I will point inverter, like whatever the inverter I have designed, it will pop up. I will add this one. Once after adding this, I will click done. Now my inverter is added and I will click home screen. So it will fit into the screen. Now what I require is for the input, I will add a V pulse. V pulse is a voltage which I am giving. And for the VDD, what I will give is I will give VDC, direct current I will give. And V out, I will now just add the port. And VSS, what I will do for the VSS, I will give the ground. Ground is necessary. As I told in the beginning only, I could have given a ground and VDC. But what I'm doing, just added the ports. I didn't use any standard libraries. And I generated a symbol and here I am adding everything. So now what I will do, here again I will click on the I, that is an instancer. And here I will go to the generate 250, spice sources. And in the spice sources, you can find vpulse first. Just find the vpulse. You can find the vpulse here or here also you can drag and find. Anywhere. Here you can drag and drop. Any option you can use. I will go to the vpulse. Here is my vpulse. I will just add my vpulse here. First I will add it and then I will make a connection. I added vpulse. Similarly, I will search for the VDC and I will select the VDC here. Similarly, I will go to the MISC and here I will add the ground. This is small GND. I will add the ground here. Once after adding all this, I will click done and I will click home button. So everything is ready. Now what I will do, I will just make a connections. I'll just delete some wire has been added. If something is added, you can delete this. You can zoom out using minus. VDC, it's not you have to keep 5. I will tell you about the VDC. So here you can see the VDC, right? In VDC, it's the 5 voltage, okay? If you double click on this, here you will get the user. And here you can change the voltage. If you are using 45 nanometer technology, 5 voltage will be higher. You cannot use 5, you will get an errors. The simulation will get failed. Whenever you use lower nanometer technology, the VDC voltage should be reduced. You can either use 2 to 2.5 volt if it is 45 nanometer technology. Since it is a 250 nanometer technology, I'm using the 5 volt. Whatever in default it's coming, I'm not changing that voltage. I'm using whatever I'm getting. And whenever you use lower nanometer technology, you have to change the voltage according to that. So for changing here, you have to do double click on this voltage. Even vpulse also, if you want to change something, here there the system will be there. Here you can make the changes. In this, nothing changes will be there. In VDC, you can change the voltage. So now what I will do, I will add the just move the ground also. Now I want wire again. I will click on the wire and VIN. Here you have to see properly. Sometimes VIN will be up, VDD will be in the middle. So you have to see and make the proper connection. And now I will click on the VIN and I will connect it to VPulse. And I will click on the VDD and I will connect to VDC. And here my VSS will be connected to both the VPulse and uh, VDC. And now I will to come out of the wire, I will click on this arrow and I will go to the ground and I will add this. Now what I want, I should add the input. So input will be given to V in, that is a V pulse. So I will add the input and I will name it as V in. Similarly, what I want next, V out. So I will go to the V out, I will add it here and I will name it as V out. Enter. Once after adding this, now I will click on the home button. Next step, what I have to do is I have to drag, I have to extend the wire to prevent the short circuit. So I will click on this and I will drag this. Similarly, I will drag the ground and similarly, I will drag the V. So similarly, now what I can do is I can go here and I can type I and I can go to the spice plot. Here I will be having the voltage print. I can add the voltage print. Voltage print will be added only for the input output for getting the waveform. So readily I will get the waveform and I will not get a plain window. Directly waveform will be displayed. If I doesn't add it, I will get a plain waveform window where I have to manually double click on the V in and V out and get the waveform. Better I will not add the voltage print. So you you should be knowing why voltage print. Voltage print is to print the simulation waveform directly. So now it is not necessary. So we'll just click done. And now everything has been added. Now what I have to do is I will click on Control S. I will save this one. After saving this, however, VDD VSS connection again is not required. Directly it will appear. However, previously I have given. Now, schematic also will be there. If you double click on this, you will get the older schematic. First, what we have to do here, we have to check the. So here, if I can click here, or either I can go to tools and click on the design check. So one cell has been checked, 0 errors and 0 warning. So I don't have any errors. So it's completed. Now what I will do is I will go to the here you can see there are options. This is for the running simulation. This is for setting up the simulation. Before running the simulation, I have to set up the simulation. I have to see whichever the analysis I have to run. We will run this one transient analysis for the timing. That too for the basic circuits and all. You'll go with the timing analysis one. That's the transient analysis. So here and also I have to give the library path before running the simulation for the T-Spice. And here I will click on the simulation. And as I told in the beginning, here we have to give the spice. And here we have analog path spice, that is AFS, ELDO and T-Spice. Complex design uses ELDO and basic simulation uses T-Spice. Very higher end uses AFS, analog path simulation. And even for the analog mixed signal, you will use the AFS. Can in other locations, you go to the computer and you go to the home. Inside the home, you go to the bibliography. And here you go inside the Tanner. Tanner where the tool is installed. And here you go to the Tanner HL. Here if you go inside the share folder, here you there are examples, okay. Here you will be having the Tanner tool example guide. Tanner tool, this one you can use. And there are tutorials, okay. Here there are various tutorials available. And for the T-Spice you have the, and for the DRC, and here for the L edit, here for the S edit. Price is a different tool. Inside this you not get. And here you can go to the designs. If you go to the designs, there are example designs. You can find like a D-latch and some RF amplifier, resonator, XOR gate, ring counter. Here there are lib.o file. You can directly open the terminal here, launch the tool, this location, directly you will get the circuit, observe how the circuit is. And if you want to do it manually, just draw the circuit in your book and you do it manually. Or else every settings will be ready, run the simulation and verify. So you have everything ready. So now why I am giving this inverter is here you will understand the tool flow. Once the tool flow you are aware, here directly you can run the example design. And then you can run your own designs. This you are not knowing, like these examples. Same examples. So, dot ratings. And some features by tool. All tool guide, whatever is necessary, everything has been given it. And some third this. Here you can find the various PDF documents. Inside the share docs PDF docs. It's all our advanced. Also, you go to the Tanner, go inside the Tanner 20, go to the share folder. Inside the share folder, you have everything. Can you continue? Yes. Okay. Now here what we have to do is here you can see we have custom T-Spice and ELDO and AFS. Whenever you are doing small designs, don't go for Eldo analog and all. Better continue with T-Spice. Whenever you go for some operational amplifiers or something, go with Eldo. If you want to do mixed signal, it's a very advanced thing. For that, AFI is necessary. Now it's not necessary. You can go with the T-Spice only. And here you can click on T-Spice. And here you can do the general settings. So here what I'm giving is show waveform as after. After in the sense, first it will run the simulation and then the waveform will get displayed. Similarly, you can enable this voltage probing, current probing, and enable waveform charge probing. Everything you can just make it as true. And see, we are waveform voltage probing, like whatever the voltage probing will take place. If you give false, it will, whenever the simulation runs, it will not consider that. When you give true, it is considering while running the simulation. If you want to consider that voltage probing, you want to consider current probing, charge probing, you have to make it true. If you don't want to consider, it's fine. And for now, this reason it's not necessary, because whenever you are running some small designs, all these things will be not necessary. Just you are doing this for the tool flow. You are not making any application design. So for that purpose, we will make it true. And here you don't make any, nothing is required to add. We have to add the library file. So for adding the library file, here you have to browse and you have to go to the home. Home in the sense you have to go to the Tanner tools. And inside the, even for the Eldo and the AFS also similar way only will do. As I told, T-Spice, no, libraries are same. No, it is a simulator. You don't get confused between the simulators. T-Spice, Eldo, and AFS are the simulators. You can use any of the simulator. Complex design uses AFS and Eldo simulator. Basic designs and the moderate designs, you can go with the T-Spice simulator. It's just a simulator. So here, what you have to do is you have to go to the Tanner tool, like whatever the setup we have done in the beginning. Here, there is a option called process. Inside the process, generic 250 nanometer. Here you can find models. Okay, inside the models, you will be having a generic 250 nanometer dot lib. So this, why I am adding this, because as the name indicates, for the 250 nanometer library to run the simulation with that particular library, I am adding this. Because I have designed the circuit using generic 250 nanometer devices. So if I want to run the simulation for generic 250 nanometer clip, I have to add this, right? In case if I have designed using 45 nanometer, I cannot go and add this. I have to choose the two models inside the 45 nanometer and I have to add to 45 nanometer dot clip. So this is the library file which is required to run your simulation for whatever the design you have designed. So now I will add this one. And after adding this, here it is been added. After adding this, here I have to give the space and I have to type capital TT. So here why you are giving TT is because it's the extension for this library file. So mainly for the T-Spice. So after giving TT, now what I will do is I will go and select the transient. And here there are various netlisting options and all. This one we will not use. Whenever you're going for the 45 nanometer technology, here you have to export the control property because it's the inbuilt library. If it's 45 nanometer is a library you are taking from outside foundry or free PDK. It is not at all considered inside the Tanner tool. You cannot directly add that as a netlisting option. You have to export that. You have to add the export control property like hspice, dspice, some command will come. Certain commands will be there while taking the some other different library PDKs that you have to add. That is different actually. So this thing is not necessary. And here we'll perform the transient analysis. You can perform any of the analysis, but for this circuit, it's transient analysis will perform now. Capital TT. You have to keep capital TT there. That also. And here, stop time, you can keep anything. I will just keep it as 1000 nanoseconds. And print start time, I'll start with 0 nanoseconds. And maximum time step, you can give 1 or 2. I'll just give 1 nanosecond as a time step. It's the time step. And a print time, I'll give as again 1 nanosecond. And other things, you just keep it as it is default. Nothing is changed. And now what I will do is I will click OK. Now what I have done, transient analysis I have selected. I have given the setup time. Once after that, in a general, I have added the library file, and here I made this all the probing as true and waveform after. And here this is spice is selected and T-Spice is selected as a simulator. Here also you can see it's written as simulator for your more understanding. And now I will click OK. And there only I can run the simulation, or else you can click OK and here there is a green color. This is to start the simulation. I will run the start simulation. So now I will get the waveform. So here you will get the window simulation finished. So if you go to the yes edit, here it should show simulation finished. And once the simulation is finished, T-Spice and Tanner waveform, two window will be generated. This is the Tanner waveform. Here it is a T-Spice file, it is loading. And here in the Tanner waveform, as I told, if I have given the print voltage, the waveform would have been displayed directly without selecting the V in and V out. Now, I have not selected the voltage print, I have not added voltage print, so I have to double click on V in. I will click on V in, I will get the V in. I will click on V out, I will get the V out. And now to separate this, here there is an option. Put selected traces on separate plots. And now it is satisfying the inverter functionality. Like whatever the design you do, you have to check whether it is satisfying your the functionality. I'll just show you one thing. I'll go to the estimate. If in case I would have selected some NAND gate. NAND gate is having two inputs. So here what you will do is you will go to the spice sources and there is a V bit. V bit will be present. Okay. V bit. I will just take the V bit. So I'll just add this here and I'll click done. If I double click on this V bit, here you can see pattern. I can give the pattern. Based on this pattern, I will get the waveform. So you can verify your truth table 001011 or 00. So you for both V in and VA and VB, like two both the VA and VB will add this V bit so that you will get the output directly. So based on that, you will get the output. Here it's not necessary, so I have not added. I will delete this one. Just by understanding, I just showed how we can add the V bit. And now you can add the voltage print or directly you can see. Now it is satisfying the functionality. Input is high, output is low, input is low, output is high. Now what we will do is, now I will go to the edit and directly here you can see the T-Spice. I'll just click on this. So if I click on this, I will get the green color. You should get the green color windows to save it as a netlist. So before directly the T-Spice will be opened, but don't go to the T-Spice directly and save the file. You click here in the T-Spice and then you go to this file. I'll maximize this screen. Now you can see this is my T-Spice. T-Spice in the sense netlist. Whatever the netlist I was telling, which will use it to LED to load it into the SDL navigator. That is T-Spice. This is the netlist. Now what I will do, I'll click on the file. I'll click on save as and I will save this as inverter test.sp. I will choose the location to save this. I will go to the home and I will go to the work folder and here inverter. I will not save inside the layout or schematic. I will save inside the inverter itself because it is the main netlist file. Don't save in any of the folder. Save inside the inverter and it will be saved as inverter underscore test.sp. You can give any of the name. It has directly taken the cell name with extension of .sp. .sp is the extension for the T-Spice file. Like how the Verilog will be having .v, VHDL will be having .vhd, system Verilog will be having .sp. Similarly, .sp is a for the spice file. I will save this. Now it is been saved. Now once after saving, this completes your complete yes edit part. Even not required. No, it's not required. However, you're getting the waveform directly. Mainly